Now what we have here is something that is quite common in problem solving, that we've got a situation where you now have to extract the key parts of information, but it's also not just about using one single equation. You need several equations, and you might be given equations, some of which you might not need, some of which you actually do need. So in this case, we're looking at what information have we been given. So we know a wave travels a certain distance within a certain time. And we also know that the wavelength is given, and we are asked to calculate a period. So in this case, now there are certain equations that you might come across, and either in your problem, in your formula sheet, or in the formulas attached to the multiple choice question, you'll find several equations, and we're looking at a period. So period, that might be associated to frequency as well in a certain way. So frequency is normally associated with a variable f. So we have equations where we can see there's an f here and f here. Now we've given a wavelength, which normally is named as lambda. We've traveled a certain distance within a certain time. So this might give us a hint of velocity. So you've got a velocity v, lambda, and a frequency. So this all looks like this equation, which reminds you of the typical equation linking frequency, wavelength, and velocity. This one is one you'll come across later, which is the thin lens equation. It has an f in there, but that's focal length. So that's not an equation that we will be using. So now, looking at this, we want to calculate a frequency. That will give us an idea of the period. We know the wavelength. We know sort of the velocity. Hang on, how do we know the velocity? Velocity is, in this case, a distance that has been traveled in a given time. So in this case, the velocity is given as, let's try to stick into these equations, SI units in meters and seconds. So 10 centimeters is going to be 0.1 meter as a distance, and that's covered in 5 seconds. So 5 seconds. If you do that, you'll get a velocity of 0.02 meters per second. Good, we've got the velocity. Now, if we've got the velocity, that's equal to the frequency times the wavelength. We know that the frequency is what we're looking for. So we need to isolate that, divide by the lambda on both sides. The lambda will disappear, isolate the f, and we're left with the velocity over, remember, divide by lambda on the right hand side, divide by lambda on the left hand side. So that will give us v over lambda. So that's going to give us 0.02 meters per second, divide by the lambda, which was 4 meters. 4 meters. That cancels. We're left over with a 1 over seconds, or later we could call that hertz, as the right frequency units should be. 0.2 over 4, 0.02 over 4 gives us, if you do the calculation, something like 0.005. So that's the frequency. Now, that's not actually what we're looking for. We know period and frequency are related. Actually, if you look at it, the frequency is 1 over the period, or period is 1 over the frequency. So now, knowing that, I can just do period is 1 over 0.005, 1 over seconds, 1 over seconds gives me seconds. So I've got the right unit. And 1 over 0.005, if you insert that into your calculator, you'll get something like 200 seconds. You're nearly there. So you've got the period in seconds, not in minutes. So remember, 60 seconds in a minute, so divide 200 by 60, and you'll get something like 3.3 minutes. That's now your period. What you've done here, in this case, is you've extracted key information. You've used your knowledge of the equations, which ones to use, and you've added additional equations to that to support your problem solving, which is all very common for slightly more challenging questions regarding problem solving and inserting and using some of your wave equations and optics equations.